Okay, today's objective is ELR 8.3. This is an important topic. We're going to be exploring and using the three main trigonometric ratios that we get from a right triangle. All right, so let's get started. I want to just practice a couple of things of special right triangles before we get into 8.3. So copy this in your notebook. Here's a trapezoid. What can you sketch in to make a special right triangle? Well, I could sketch in a altitude going up this way to make this a 90-degree angle here, right? So that means that this is 30 degrees left. So we have a special right triangle on this side here. All right, we need to figure out A and B here. So what can we do? Well, we know that I could bring this side over. This is 2 root 3. That's the side that is opposite of 60, right? So the side opposite of 60, let's make that right triangle again, that special right triangle. The side opposite of 60 is x root 3. The one opposite of 30 is x, and the hypotenuse is 2x. So if my side opposite of 60 is 2 root 3, that means that this is my x, the 2. So that makes this little piece here opposite of 30, 2. That makes the hypotenuse, which is this A side, 2x. So that's 2 times 2. So that gives me 4. So A is 4. Since I have this length of 2 here, and I know that this 6 is the whole side length, I'm going to take 6 and subtract 2 from it to get me the B, which is 4. So B is 4. All right, I want you guys to try this next one. What's the value of A and B here? Copy it, pause the video, see if you can get it. Okay, I sketched in my altitude. I made a 45 degree 90 right triangle. I put the diagram below. It's x and x root 2. So we know the 3 root 2 side is the hypotenuse. To get the legs, which are the x side, since this is x root 2, the x must be 3. So this is 3, this is 3. All right, I could bring down this 4, right? From here to here is 4, so that means from here to here is 4. So that makes the whole thing, 4 plus 3 is my B value, which is 7. And then I could bring this side over, because that's the same as the A side, so A is 3. All right, 30 seconds, think about what is trigonometry? What does this topic deal with? Well, trigonometry is the study of sides and angles in right triangles. So you might have heard this maybe from somebody in your house or a friend, SOHCAHTOA. This is a thing like PEMDAS, or PEMDAS from Order of Operations, something for you to use to remember the formulas for SOHCAHTOA, sine, cosine, and tangent. All right, so here is this next slide. Definitely pause this, copy this table down. We have our names of 3 different trig ratios. One's called sine, one's called tangent, and one's called cosine. So if we wanted to find the sine of an angle, we would be doing the opposite side divided by the hypotenuse side. Sometimes you might see it abbreviated like this. If I'm doing cosine of an angle, that means I have adjacent side over hypotenuse. And I have, if I'm looking for tangent of an angle, is opposite over adjacent. So how do these 3 things match up with these formulas? We'll take a look. Here is the S, correct? This is the S for sine. Sine is O and H. We'll take a look at the equation, O divided by H. Then we have the letter C, which represents cosine. A over H, and what's the equation? Adjacent divided by hypotenuse, A over H. And T stands for tangent, which is O over A, or opposite over adjacent. In these formulas down here, something got cut off. If we are looking for an angle. Ignore that, we're going to talk about that in the next slide. All right, so let's see how we're going to use this in a right triangle. All right, here's this picture of this triangle, GRT. They have different sides here on that right triangle. All I'd like you to practice right now is how to get the ratios first. And then we'll be using our calculator. So we're looking at angle T. So you put your pencil point on angle T. It's asking you to find the ratio for sine of T. Sine was opposite divided by hypotenuse. What's the opposite side of T? That's 8. And what's the hypotenuse side? 17. Same angle again, you're at T. We want the cosine of T. Well, what's the adjacent side? The adjacent side has to be the one that's right next to T. That's the 15, right? Can't be 17 because 17 is the hypotenuse only. 15 over 17 is the ratio for cosine T. And then for tangent is opposite divided by adjacent. What's opposite of T? 8. And what's adjacent to T? Again, that is the 15. All right, we're going to use the same picture and do the same thing for angle G now. You could pause the video and see if you can get these three ratios. All right, here are the three ratios for angle G. So I have my pencil point on G. What's the sine of G? Opposite, which is 15. Hypotenuse 17. Cosine is adjacent. 8 is adjacent to G because 17 is the hypotenuse. And then tangent of G is opposite divided by adjacent, 15 over 8. Do you think you could use trig ratios for angle R? Why or why not? Definitely not, because how are you going to get, opposite over adjacent, right? Opposite looks like it's 17, adjacent could be 8 or it could be 15, right? Impossible to get values for trig functions from the right angle. So this, as you move on later on in Algebra 2, you'll learn more about that. All right, here's where you need your calculator if you have a TI, or you're going to use the Desmos calculator online. I'm going to show both ways in this video. So here is this right triangle. You have 14 as a side, 67 degrees as an angle, and then you have the unknown side, x. So the first thing you want to say to yourself is, put your pencil on 67. What is the relationship of the side that I have and that I'm looking for in respect to 67? So think about it. This side that I'm looking for is opposite of 67. So we know we have an opposite. And what's the relationship of 14 to 67? That's adjacent side. So what's opposite and adjacent? That is the formula of tangent. So let's write that down, the formula. So tangent of an angle is equal to my opposite side divided by adjacent side. What I'm going to do here now is plug in everything that I have in the equation. So I'm doing tangent. The angle is 67 equals, what was the opposite side again? That was the one I was looking for, x. The adjacent side was 14. Now I have an equation that I need to isolate and move things around to get my x, correct? So I'm going to be multiplying here. I'm going to put this over 1, and I'm going to cross multiply. So this times x is x. And then 14, I'm going to be multiplying it by tan 67. So 14 times tangent 67. This little thing here on the right-hand side, hopefully you could see it. This thing here, I'm trying to enlarge a little bit more now, is on the Desmos, on the online thing. So if you go in there, make sure first that you are in DEG mode, degree mode first. That's real important. Once you are in degree mode, you could take a look. Here are the three functions that we're using, sine, cosine, and tangent. Well, we're going to plug in 14 times tangent 67. Enter. There is the answer there. Oops, it got cut off. What is this answer? 32.98. If you have the TI calculator, here is a cutting of the screen so you could see it. First thing you must do when you go in is press, see if everyone can see it, this mode button. When you press the mode button, you must go down and make sure that you have selected in black degree. So highlight degree and press enter. Once you have that, you could go and exit out, second quit, out to the main screen. These are the 3 buttons we're going to be using, sine, cosine, and tangent, right? So we're doing 14 times tangent 67, enter, and we get the same answer that we got from before. All right, next example. Make this right triangle. Find the length of side C. So we're looking for this one here. We have 25 degrees and we have 8. They're not asking us to find this, so I'm just going to get rid of it. So what is the relationship of the 25 degrees with 8 and with C? So C is the hypotenuse side, so we have H. And what is the relationship of 8 to 25 degrees? That's the adjacent side. So what trig function is adjacent divided by hypotenuse? Well, that is cosine. So I'm using cosine here. So I'm going to write down the formula. Cosine of the angle equals adjacent over hypotenuse. Let us plug in what we have. Cosine 25 degrees equals, my adjacent side is 8. My hypotenuse side is the unknown, C. I am going to now do the same thing I did before, cross multiply. So C times cosine 25 to equal 8 times 1, which is 8. Now, if you notice here, we still need to do one extra step because cosine 25 is attached to C. This is a thing that's together. You can't separate the angle with the function. So we're going to divide cosine 25 over. So in the calculator, this is what we're going to be doing. 8 divided by cosine 25. So I have the TI calculator on the left, and I have the Desmos calculator on the right. And the answer comes out to be 8.83. Okay, now, what if they're asking us to find an angle instead of a side in a right triangle? All right, so now, here are something new, a new button that you have to press for this one here. So these are the 3 that I'm going to be using. If you notice there, we have a symbol raised to the -1. So sine inverse to the -1, cosine to the -1, tangent to the -1. These are going to give me my angle measurements. I need to show you how to get them on the calculator too. All right, so let's take a look at the triangle on the left. So definitely write down those 3 things to find an angle. This is what you're using. All right, we got HBX. We got a side of 6 and a side of 10. And we are looking for this angle here, angle X. All right, so the first thing you got to do is say to yourself, okay, what is the relationship of 6 and 10 with angle X? Is it opposite? Is it adjacent? Is it the hypotenuse? All right, well, 6 is opposite of X, so we have an opposite side. 10 is not adjacent, right? That's the hypotenuse side. So what trig function is opposite divided by hypotenuse? That is sine. So I need to, I'm going to erase this. I need to now write the equation. So we know it's sine. We're looking for an angle, so it's to the -1. And in parentheses, we're going to put opposite divided by hypotenuse. And that's going to give me angle X. So let's plug in the 2 numbers in the right spot. My opposite side again was 6. My hypotenuse side was 10. Now, I am showing you the Desmos calculator version online. Now, on the main screen, when it says main, you don't see these -1 things, right? So up here, right here, let's do it in red, you must press the function key. And here are the 3 things that we're going to be using. We're going to be pressing sine to the -1. So go ahead and press that. Once you've pressed that, you need to go back to the main screen again so that you could plug in your numbers. So once I have my function first and I get sine to the -1, now I'm going to go back to the main screen and press 6 divided by 10. And I get the angle to be 30, says to the nearest degree, 37 degrees is angle X. All right, on the TI calculator, If you take a look at sine, cosine, and tangent, do you notice the things that are written above them? In blue, I believe, or yellow. Sine to the -1, cosine to the -1, tangent to the -1. Well, to get that thing above those three buttons, I must first press second and then that function. Here I'm using sine, right? So I must press second sine, then this lovely thing will come up, sine to the -1. So go ahead and try that. And then you put in 6 divided by 10, and we get the same answer of 37. All right, we need to go back to the other problem that I have on this slide, M and X. Okay, so let's make this triangle, M and X. And what was it again? It was 15 and 20. This was 15, this was 20, and again, we're looking for angle X. All right, so let's look at X. What's the relationship of 15 and 20 with angle X? All right, 15 is adjacent. 20 is the hypotenuse. So what's adjacent divided by hypotenuse? That is cosine. Since we're looking for an angle, we're doing cosine to the -1, right? All right, let's plug in those two numbers in the right spot. So the adjacent was 15 and the hypotenuse was 20. All right, so I have both versions. On the right is the Desmos, on the left is the calculator, just making sure that you understand what buttons to press. So for this one here, we're doing second cosine to get to the -1. Here, you must make sure that you press function first to get that cosine -1, and then back to the main to get the numbers. We plug it in, and it says the answer is 41 degrees for angle X. All right, last problem. We want to find the lengths of the diagonals of a rhombus. The lengths of the diagonals are 3 and 5. Find the measure of the angles of the rhombus to the nearest degree. All right, so we got to remember all our quadrilateral properties. So let's make a rhombus. We know that in a rhombus, the diagonals bisect each other. So if one whole diagonal is 3, that makes each of these pieces 1.5 each. That's a total of 3. The other diagonal is 5, so that makes this 2.5, 2.5. And we have right triangles. So we have 4 right triangles that are all identical here. Let's take out one of them so that we could see it better. So I'm going to take out this one here. Let's make it 2.5, 1.5. All right, we need to get those two angles here. I'm just going to label it ABC, just to make life easy for ourselves. All right, once I have one, I could find the other one. So it's up to you which angle you want to find first. Okay, so let us go ahead and find out angle C first, this one over here. So I'm looking at the sides in respect to angle C. 1.5 is opposite, 2.5 is adjacent. Since I'm looking for an angle, we know we're doing that to the -1. Which function is opposite over adjacent? That's tangent. So tangent to the -1. I'm going to plug in those two numbers. Plug it into the calculator. If you have the TI, go ahead. And I'm getting this answer here. It says to the nearest degree, I got 31 degrees. So that makes this angle here, I knew it was going to do that. This angle here, oops, is 31 degrees. We could do 180 minus the 90 plus the 31, right? And that gives us an answer of, let's see. That gives us an answer of 59 degrees here. So if I was to put this back in here, we know this is 31, this is 31. So this whole angle here is 62, which makes this whole thing 62, right? This angle here is 59 plus 59, which gives us a total of 118 degrees, and this is 118 degrees. So these are the angles of a rhombus, 62 and 118 degrees.